Hello, this is Miraj Patel, and today we're going to be finishing up the material for the kinematics section of Miraj's physics videos. And today we're going to be talking about 2D kinematics and projectile motion and all that stuff, as you can see. So, two-dimensional problems, just like one-dimensional problems, there is a specific strategy that you should always use. And here's some important pieces of information you need that are crucial to solving two-dimensional problems in kinematics. So, in two-dimensional problems, there is a horizontal and vertical component. And here's some key features. The two components, the vertical and horizontal components, are independent of each other. Believe it or not, the horizontal and vertical components are independent, and I'll show you what that means, or I'll tell you more about it as we solve problems. The acceleration in the y direction is always 10 meters per second squared downward, so it's always gravity. And in the x direction, it's always 0. There's no acceleration in the horizontal or x direction. The projectile is in the air, or the time the projectile is in the air is only affected by the height. So it's only affected by how high it is. So, for example, if you have a bullet and a bullet shot out of a gun, and they're at the same height, and you fire the gun and drop the bullet at the same time, they will hit the ground at the same time. And there's actually a Mythbusters episode about that if you want to look it up. But projectiles, the height is the only thing that affects how long it's in the air. So that's what I mean by they're independent. The y direction's always 10 meters per second squared negative. The acceleration, the x direction always has no acceleration. The time is only affected by the height of the object and how it travels. So this is what I mean by they're independent. And also the range of the projectile is always the initial horizontal velocity times the time. So this is another way they're independent. The range is only affected by the time it's in the air and the initial velocity. And the only thing that they share in common is time. So time is the key factor to solving two-dimensional problems. And always split the problem up into two components and solve them independently. Then bring them back together to solve the final piece. So I always suggest that you solve for time using the y component first. Then you go to the x component and see if you need to solve like the range or any other piece of information. And as you can see from this graph, the x component velocity always stays the same. So it's always constant because acceleration in the x is 0. But in the y direction, it's always changing because gravity is always affecting the object in the y direction, always. So the first type of 2D kinematics problems we're going to solve are horizontally released projectiles. And the special thing about these projectiles is that they are launched at a 0-degree angle. So basically, they are just shot straight parallel with the ground. So they have no initial vertical velocity. So their vertical velocity, so in the y direction, is 0. But they have a horizontal velocity. They only have an initial horizontal velocity. So So the horizontal velocity is this direction, so they have velocity that direction, but the vertical direction, like this, has a zero as its component. And the time it takes to solve, the time it takes for it to hit the ground is uh, is the most important piece. So you first just analyze the y component and find out the time it's in the air, and then you can easily find the range. So here we have a horizontally released projectile. A cannon is fired off a 100-meter cliff. The cannon is set to fire a rubber ball at 150 meters per second. How far can the cannon shoot the ball? Okay, so if you're a visual learner, or you just need help to visualize a problem, it is pretty important to draw a picture of the problem. When you're first learning how to solve these problems, it's very helpful to draw a picture. So here I have a pretty picture I drew on Microsoft Paint. So here I have a cannon, there's a ball. This is a dotted trajectory of the ball, and it's off a 100-meter cliff, and the initial velocity is 150 meters per second. So what we won't need to find is the range. So how far does this little ball go? So, like I said, first we need to split up the components into x and y and pull out everything we need. So, in the y direction, acceleration is always 10 meters per second squared because gravity always affects in the y direction. So the acceleration in the y is 10 meters per second squared. Initial velocity in the y direction is 0 because the ball is fired horizontally. So there's no component of this velocity that's in the vertical direction. In the vertical direction, it's equivalent of being like dropped. And then the displacement until it hits the ground is 100. So there's 3 pieces of information there. In the x direction, we know 2 things. The acceleration is 0, and the initial velocity, or the velocity, is 150 meters per second. And we need to solve for the displacement in the x direction, or the range. So since we have 3 pieces of information in the y direction, I'm guessing we need to solve there first. And what are we trying to solve in the y direction? Did you say time? Well, if you did, you're correct, because time is what unites the 2 directions together. So time is the only thing that's related between the 2 components. Always solve for time in 2-dimensional kinematics because time is what relates the 2. So here are our givens again we just talked about. Acceleration is 10 because gravity. Initial velocity is 0 because it's a horizontally released. So it's not moving vertically initially. And then its displacement is 100. So we have these variables and we need to solve for time. So we can use this equation, Galileo's. So because it has all 4 variables that we want, time, acceleration, initial velocity, and displacement. It doesn't have final velocity. So Galileo's is what we need to use. So we first write down the equation, plug in everything we have. So we need to solve for t. So 100 from 100 meters. Initial velocity 0, 1/2, acceleration is 10 because gravity, time we're solving for. This initial part goes away because multiplied by 0, so you can just cross that out. So the next part is 100 divided by 5 because 1/2 times 10 is 5, and I just moved it over, equals t squared. So 100 divided by 5 is 20, so square root of 20 is time, or that's about 4.47 seconds. So that is the time the projectile takes, or the ball takes, to hit the floor. So now that we know time, we are almost done. So now that we have time, you can find the range because they both share that one piece, important piece, time. So the givens for the x direction is that the acceleration is 0 meters per second squared, velocity, initial velocity, is 150 meters per second, time is 4.47 seconds. So using this, we want to find x. So which of the following equations doesn't have a final velocity? And that happens to be Galileo's equation again. And so we plugged in all our information, and since acceleration here is 0 here, we can cross out the second part. So we're basically left with distance equals rate times time. So this is your classic equation when it's moving at a constant speed. Distance equals rate times time. So the range is 150 times 4.47, or 607.5 meters. So this cannon can shoot 607.5 meters. So that's pretty far. So now let's talk about non-horizontally released projectiles. So these are actually curves, like more parabolic curves. And there's several more pieces of additional information you need to know about curved trajectories like these. The two sides are symmetric. As you can obviously see, this side mirrors the other side, and they're pretty much the same lengths, same height, same points at the same times on either side. In the y direction, at the same height, the velocities are the same but in the opposite direction. So at this height here, the y velocities are exactly the same but opposite direction. So this arrow and that arrow are the same length but facing opposite because gravity is conservative. Remember, gravity is always conservative. And same thing at the ground, the initial y component is the same as the final y component, except that they're opposite signs. So that's what this means. In the y direction, at the same height on either side, they're the same magnitude, or they're the same speed but opposite direction. One's going up, the other's going down. The y direction, the velocity at the top is 0, like we talked about. When you throw up a ball, at the top, it's gonna be 0. It's not moving at all vertically. The net velocity, or the velocity it's moving at, is always tangent to the path. And tangent just means that it's touching at one point. So this middle arrow is a tangent. This arrow is a tangent. That arrow is a tangent. So they're just touching at one point. So the net velocity, or the combination of these two components, is the total velocity, and it's always tangent. And you can use Pythagorean theorem to find the net velocity if you have these two components, x and y. And Pythagorean theorem is just a squared plus b squared, or a squared plus b squared equals c squared, or in this case, a is the hypotenuse, so it's a squared equals b squared plus c squared. So basically if you make this into a triangle, so move this line over, the x component squared plus y component squared is the net velocity squared. So that's an important piece of information. And so before we continue into our problem, you have to know a little bit about vectors. So we talked about vectors are points with arrows sticking out, and basically they represent a magnitude, and then the arrow represents the direction. So the length of the vector represents the magnitude, and then the arrows represent direction, point to the direction. So like a very long vector has a lot of velocity, while a shorter vector has a smaller velocity. And then vectors can be broken up into components using trigonometric functions. So this is the most important piece of information you need to know and how to do it. So using sine and cosine and the ratio, we can solve for the x and y components. So here's the example I'll show you here. So we have vector r, angle A, and so let's solve for the y component. So knowing that sine of theta, or A in this case, is opposite over hypotenuse, so opposite's going to be y, and then r will be the hypotenuse. So sine of A equals y over r. So if we want to solve for y, we move r over to the other side. So sine of A equals y. So that's how you break up the y component. So the y component is r times the sine of theta. So if it's measured from the x-axis, r sine of A is always the y component. The x component, we just use cosine instead. So cosine is adjacent over hypotenuse. Remember SOHCAHTOA, it's in like an acronym to remember. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. TOA is tangent equals opposite over adjacent. So using that acronym, cosine of A is x over r. So x is adjacent, r is hypotenuse. So to solve for x, you move r to the other side. So r cosine A equals x. So if the angle is measured from the x-axis, the vector times the cosine of the angle equals the x component. So here is our problem. We have a soccer player kicks a ball at 30 degrees at 50 meters per second. How long does it stay in the air, and how high and how far does it travel? So here I drew a nice picture. So we have a soccer player that's obviously a huge giant, because he's pretty much as tall as the trajectory. So we have 50 meters per second as a vector, and then at 30 degrees. And so we need to find the time, the height, and the range. So first we want to solve for time, which is only affected by the height, by the way. And then we can solve for the height, and last we can solve for the range. So first we got to split up our information, the x and y direction. So we're going to start with the y. Y always gives us time. So here are the givens. So using the knowledge I just gave you, remember the vector times the sine of the angle is always equal to the y component. Sorry, this should be a y here. And then the vector times the cosine of the angle equals the magnitude of this angle, this vector. So it's important that these little things here always gives us the magnitude of the two vectors. So 50 sine of 30 gives us the y magnitude. 50 cosine of 30 gives us the x magnitude. So here we have the y magnitude is 50 sine of 30. So this just says initial velocity in the y direction. So v sub I y. So I for initial, y for y direction. Final velocity in the y direction, v sub fy, is the exact opposite because gravity is a conservative force, so it's going to give back what it takes. So the final velocity at the very end is exactly opposite, 50, negative 50 sine of 30. Acceleration in the y direction is 10 meters per second squared because gravity, yes, you got it, gravity. And at the peak, we know the y velocity is zero because it stops at the very top for a second. So, if we use our information and we know that we want to solve for time, um, let's use the acceleration formula or the definition of acceleration. But a good question is, what should we use for the final velocity? The peak velocity or the final velocity? So either one will work. This is a good question because in kinematics problems, you can change your perspective. You can call this the initial, this point the final, this the initial, the last point the final. You can call this point the initial, this point the final. You can change what you call which point. So as long as you stay consistent when you're doing the calculations and follow through until you're done, solved it, it does not matter. So I'm gonna solve it using both ways to show you. So you just have to double the peak velocity because this is half. So you just have to remember just to double the peak one if you used it. So here's the definition of acceleration right here. So final minus initial over acceleration, or over acceleration gives you time because we switched acceleration time, uh, just to solve for it. So if we use final velocity, which is negative, minus initial, because always delta is final minus initial, we get 5 seconds. Or if we use the peak, which peak is final, so it's going to be 0 minus 50 sine of 30 initial, divide by negative 10 because gravity is negative, gives us 2.5, but we have to double it because it's half the parabola, and we know it's symmetrical. We can just double it, and we get 5 seconds. So always remember to put your units. So don't forget like I did here. Always put your units. So now that we know the time, we can solve for the height. So we have the initial velocity here, final velocity, acceleration, peak velocity, and now we have the time. So this is our new information, time to peak. So this is half the time of the overall thing. In fact, we could have solved for the height without time, but if we know the time, it gives you more options. So I'm going to use the average velocity equation here, but you could have used the energy equation without even knowing time. So we could have solved for the height first, but let's use the time because we use it. So we have final velocity is the peak because the peak is what we're trying to get to. We're calling that the final. Initial velocity is 50 sine of 30, and 50 sine of 30 comes out to be 25. And we divide by 2, we're going to take the average, and multiply by the time. So 2.5 is the time to get to the top. And we get 31 and a quarter meters. So that is pretty tall. That's like about 120 feet, or 90 feet, sorry. So you just multiply meters by 3 to get about feet. So that's a pretty tall kick there. And it's always important, you must call the peak the final point in this case, because the peak is what you're trying to get to. We're trying to find the displacement to the peak. So the peak has to be final point. Or you can call that the initial point and call the final point the bottom. But the peak has to be included somewhere in this solution. The range here. So now that we have the time, you need the time to solve for the range. So now that we have the height and the time, we can solve for the range. We know acceleration in the x is 0 because there's no force in this direction, in the x direction. And the initial velocity in the x direction, v sub I x, equals 50 cosine of 30 meters per second. Time is 5 seconds because we just solved for that with the height. Unknown is the displacement, or x. We use distance equals rate times time, or pretty much the first part of Galileo's equation, because acceleration is 0, so you cancel out the whole second half. So 50 cosine of 30, which is the magnitude of the x direction velocity, times 5, gives us 217 meters. So this soccer player kicked the ball 217 meters approximately. And to incorporate what we just learned and putting it all back together, let's find the net velocity at the end of the trajectory. So we need both the x and y components to find the net velocity using Pythagorean theorem. X component is 50 cosine 30, which is the same as the beginning. And why is that? And here, I'll tell you right after I read this. So the y direction, so the x component is 50 cosine 30. The y direction is negative sine 30. And why is this true for both of them? So tell me. So just look back and think about it. And if you don't know, just listen in. And so basically, 50 cosine 30 was the initial velocity. And since there's no acceleration in the x, it's always the same. So even at the end, it's the same. In the y direction, since gravity is conservative, say it with me, gravity is a conservative force, it gives back what it takes. So, but it gives it back in the opposite direction. So it pretty much fights against it. So gravity will flip it upside down. So pretty much instead of going upwards at the same speed, it'll go downwards at the same speed. So it's negative 50 sine of 30 instead of positive. So gravity is a conservative force. That's why the y is exactly opposite. So if we use Pythagorean theorem, a squared plus b squared equals c squared. So 50 cosine 30 is the x component. If we square that and add it with the y component squared, we should get the net velocity squared. We take the square root of the sum of these two first. We get the square root of 2500 equals net velocity, and that in fact is 50 meters per second. So this proves that gravity is conservative because the initial velocity that the player kicked the ball was 50 meters per second, and the final is also 50 meters per second. So we know that we did this problem right. And theoretically, the angle here, or it should be with the ground here, right outside here, should be 30 degrees also. So it is in fact symmetrical. Thank you for listening to my video today. I hope this was helpful. And so today we learned how to solve two-dimensional kinematics problems using some trig and breaking up vectors and solving them independently, the two components. Tune into next week's video about a review of all the kinematics that you hopefully learned with my videos. If you have any questions or if you're confused, play the video again, ask your physics teacher, ask your friends, ask other people you know for help, and you can even ask me. But if you if you enjoyed this video, please tell your friends, family, people who you know that are taking physics, and please like the video and subscribe to my channel. Uh, Email me any questions. So, like, let's just say you didn't understand how to break up vectors or you want some more explanation. Please email me at mpatelbuccaneer@gmail.com. I am happy to answer any questions you have and talk to you, and please let me know about how these videos are. And before I sign off, I would like to, if you need any practice, please visit, there's this one website. If you search up OpenStax physics textbook online, you will find a textbook by Rice University, and this is what my AP Physics teacher gave us as a resource, and it has tons of problems in kinematics, and kinematics I believe is like the first or second section, and there's one-dimensional, two-dimensional, and there's even vector problems. So if you can look at that if you're want more practice and refresh yourself. And it's a book all about physics, the ins and outs, and stuff even beyond just my AP1 level class. So again, visit my another website, buccaneerchemistry.weebly.com, for chemistry tutorials if you're taking chemistry. And I hope this was helpful, and hopefully we'll see you next time. And have a good day.